In this video, we are going to determine all of the asymptotes for the function f of x equals negative x squared minus 2x plus 4 divided by x plus 3. Now remember, this particular function is a rational function because it is a polynomial over a polynomial. And we first want to see if this function simplifies at all. The only way to do that is to see if the numerator factors. So we have 3 terms in the numerator, and because we do have a leading coefficient that is negative, I'm going to go ahead and factor out the negative from the numerator, from all of the terms in the numerator, because it's so much easier to factor when the leading coefficient is positive. So once I have that negative factored out, I'm going to try to factor x squared plus 2x minus 4 into 2 binomials. So remember, I'm basically looking for 2 numbers that will multiply to give me negative 4, and those same 2 numbers need to add to give me positive 2. And there are no values, no integer values at least, that are going to work. So this numerator does not factor any further, which tells me that I cannot simplify this function. So if we were to be able to simplify it, you'd want to simplify it first before moving on to find those vertical asymptotes. Now, the vertical asymptotes are going to happen when the denominator is equal to 0. So in this case, x plus 3 will equal 0 when x is equal to negative 3. So there's one of our asymptotes. That's our vertical asymptote. Then to find a horizontal asymptote, we're going to take a look at the degree of the numerator compared with the degree of the denominator. Now, the numerator, the degree is going to be 2 because the degree is the largest exponent of the variable. And in the denominator, we have x plus 3, and that's just x to the first power. So the denominator is degree 1. And when the numerator degree is bigger than the denominator degree, you are not going to have a horizontal asymptote. So this will be none. Now, when the numerator's degree is exactly 1 greater than the denominator, then that is when we will have a slant asymptote. Some people also call these oblique asymptotes. Both of those words are acceptable. And to find the oblique asymptote, we have to go ahead and actually divide. We're going to divide x plus 3 into the numerator negative x squared minus 2x plus 4. So if we were going to do this with traditional long division, it would look like this. X plus 3 divided into negative x squared minus 2x plus 4. But in this case, because what we're dividing by, this x plus 3, which is our divisor, since it's in the form of just x plus a constant, we can certainly do synthetic division. That's going to be much easier than doing long division, or more efficient at least. So remember, when you're doing synthetic division, you're going to take that divisor and set it equal to 0. So finding the 0 of that divisor, which will be negative 3, and that's the number that's going to go in the box. And whether you set up your synthetic division like this, with the negative 3 in the box, or whether you prefer to set it up with a vertical and horizontal line like this, does not matter. The process is going to be the same either way. My preference is the box. So I like to have my negative 3 in the box. And then remember, we are putting the coefficients of each term over here. So negative 1 is my first coefficient, then we have negative 2, and then the constant is positive 4. And the process is we're going to bring down the first value, which is negative 1, and then you're going to multiply that number by the number that is in the box. So in this case, negative 1 times negative 3 will give us positive 3. And then we're going to add straight down. Negative 2 plus 3 is positive 1, and then we're multiplying by that number in the box again. 1 times negative 3 is negative 3. And then we'll add straight down and get 1, which is our remainder. Now, when we're doing synthetic division to help us get the slant asymptote, we can ignore this remainder. It's going to be insignificant as x becomes a very large number. So because it's insignificant, we're going to ignore it. And we're just going to use the values here that we have at the bottom of our synthetic division, which are -1 and 1. Now, since we're dividing x into an x squared term, we know that the exponent is going to be 1 less. So x divided into x squared means we'll be left with x to the first power. So this -1 means we have -1x to the first power, and then the +1 is just the constant. In other words, this is the line y equals -x plus 1. And this is the equation for our slant or our oblique asymptote. Y equals -x plus 1 will be the slant asymptote for the given function.